Hello and welcome. What is reinforcement learning? Well, to understand that, let's take a step back and look at what traditional computer science has done. Traditionally, programmers have written instructions for computers to execute. Yeah. Now, there is a new paradigm that actually reverses this. So instead of giving instructions to computers, we give examples to computers, and the computers learn the instructions or the rules from these examples. Here's an application. If you want to translate text from one language to another, if you write down all the rules for the grammar and the words, well, it's going to be really difficult to translate this German sentence into French, for example, or English. Also, if you want to classify what are these objects that you see in the street, pedestrians, cars, buses, and so on, and also this actually is moving, then it's going to be extremely difficult if you want to write precise instructions. So learning from a lot of pictures that have been classified gives you a better way of getting right what is in this picture. And the success actually in this area was largely due to supervised learning, which is one part of machine learning, and where you need lots of labeled data, and you need to observe the ground truth, the correct output, and the labels as an input. So that's also the challenge, because you need a lot of labeled data. And there are other approaches as well in machine learning, unsupervised learning, that doesn't need labeled data. But the problem is that you might have concept drift if you don't know the ground truth. So you find patterns, but well, you can never prove what these patterns actually are in the ground truth. There are also mixed methods like semi-supervised learning, which mixes labeled and unlabeled data, and reinforcement learning, which is the topic of today, where we learn without having labeled data, but by trial and error. And the idea comes from animal psychology, where positive reinforcements are pleasure and food, and negative reinforcements are pain and hunger. So reinforcements have been used for centuries and even millennia to train animals. So now let's do that with computers. And that's the idea of reinforcement learning, which is known also as optimal control, approximate dynamic programming, neurodynamic programming, and many other names. So a basic definition could be that reinforcement learning is an area of machine learning inspired by behavioral psychology, concerned with how software agents ought to take actions in an environment so as to maximize some notion of cumulative reward. And to better understand this, here is a picture where you see an agent that takes an action, interacts with the environment, and then moves into the next sequence and repeats all of that all the time, with the objective to maximize total rewards. Now let's look at some applications and examples to get a better understanding of what this means. In computer science and other sciences, reinforcement learning has been used a lot. And the early successes were in backgammon game playing, in Atari game playing, or also in the game of Go, which is one of the most recent successes of reinforcement learning. Elevator scheduling, helicopter control, spoken dialogue systems, ChatGPT, data center energy optimization, self-managing network systems, and autonomous vehicles. They all work with reinforcement learning. Now, in the social sciences, operations research has used reinforcement learning for pricing and vehicle routing. And computational finance has used reinforcement learning for portfolio optimization and algorithmic trading. Now let's take a look at an example from operations research. Here, vehicle routing has a couple of components that you need in your reinforcement learning application. So you need an agent. What's the agent? That's the vehicle routing software that selects the best route. Also, you have an environment. That's stochastic demand. So you don't know where the demand will be high or low. That's by chance. Your state is the vehicle location, the capacity, and the depot requests, and you might also have some other state variables. So the action is then to choose the best vehicle route. And the problem is, well, traveling costs money. So we want to maximize our rewards by reducing the travel cost. So that's why there is a negative travel cost as a reward. Another example is the game of Go, and it's one of the oldest and hardest board games to play. It has more configurations than chess. The agent here is the player, the environment is the opponent, and the state is the board configuration. The action is the next stone location, and after you play the whole game, you either win or lose. So that's the reward. So in each step, you get no reward. You have delayed feedback. Only after playing the whole game, you know whether you won or lost. And in 2016, AlphaGo actually defeated the top player from Korea, Lee Sedol, 4-1, where it played actually using reinforcement learning techniques. And that made it possible not only to learn by examples from how other top players played, but also to improve its playing by things that no one would do. And in move 37, AlphaGo actually did a completely unexpected move, which made all the commentators actually scratch their head. And you can watch the YouTube documentary on this, which is really interesting. Now also robotic control is one application of reinforcement learning. Here we have a helicopter control where the controller is the agent, the environment is the helicopter, the state is the position, orientation, velocity or angular velocity, and the action is to choose the collective pitch, cyclical pitch, the tail rotor control, and in competitions you have a trajectory that you need to follow. And if you deviate from it, you get a penalty. So the rewards are the negative deviations from the desired trajectory. And here also there was a breakthrough from a Stanford researcher that actually won against humans in a competition. Conversational agents, ChatGPT. Here the agent is the language model, the environment is the user, the state is the conversation history, and the action is the next token or the next utterance. And the reward is ratings based on task completion, user satisfaction, and so on. And this is today an active area of research. Computational finance, here we have it as an example, automated trading, where the trading software is the agent. The environment are other traders, the state is the price history. You can buy, sell, or hold, and the reward is the amount of profits that you get. Adaptive field experiments, lab experiments, or survey experiments are also applications of reinforcement learning, and we will see some examples of that during this course. Advertising, that's something that Google does actually with reinforcement learning methods. Educational learning. Labor market platforms use RL. Public health interventions, social program targeting, and crime prevention and policing. Political campaign strategy, should I use this ad or this ad for my campaign? Also, you can use these methods for explaining behavior and assisting decision-making in game theoretical problems, in household choices or firm choices. Now, this course starts with multi-armed bandits, which is a really cool set of reinforcement learning methods. Then we go into the Markov decision processes and understand what is behind everything. Then we look at the most important reinforcement learning algorithms and finish up with deep learning reinforcement learning algorithms. So here are some references where you can take a look at and learn about learning with reinforcement. And the takeaways for this session is that we have seen what is reinforcement learning. It's a comprehensive form of machine learning where you have an interdependent sequence of decisions. You have an incomplete model. You don't know the rewards. You have a stochastic environment. You have no supervision and partial delay or delayed feedback, like in the game of Go, where you only know after you have played the complete game if you won or lost. And the long-term goal is to make autonomous agents without needing explicit supervision. So according to ChatGPT at least. So thanks for watching, and see you in the next video.